Morning, everyone. So today is the second last day of this FDP, and as I said yesterday, today I'm going to discuss correlation and regression. So I don't think so. I need to summarize all what I have discussed previously. I'll come directly to the today's topic, that is correlation and regression, and at the end I'll try to summarize everything. Right. So give me a second. I'll share my screen first. Okay, I think I shared the screen. Is it visible?
जी मैडम.
Thank you. Yes, thank you. So we have seen parametric and non-parametric tests previously. Today I'll talk about correlation and regression in the category. So firstly, I'll talk about the conceptual aspect of correlation and regression, and then we'll see how we apply these two tests using the Excel, right? So I'll take the first term, that is correlation, right? So can anyone give me any idea that what do you understand by this correlation? If you are having
Between variable dependent and independent variable.
I think one by one, if you will speak, it would be better for me to listen and for everyone to listen to you people.
And correlation is the relationship between independent variable and independent variable.
Okay. Okay, fine. Anyone else?
It's only a relationship, not a cause and effect relationship.
Okay, fine. Very good. Any other opinion?
Ma'am, any two variable can be seen. Relationship between any two variable, whether it is both independent or independent dependent.
Very good. So I think two of you, I think Vijay sir and I don't know the last one, ma'am, who was speaking to me?
Malvika ma'am.
Malvika ma'am. So Malvika ma'am and I think Vijay sir said it is a relationship between the two variables, that is dependent and independent. But my dear friends, I need to tell you this thing. When we talk about correlation, correlation cannot differentiate between the dependent and independent variable. That is the limitation of correlation. So in the simple words, if I will define correlation, I can say correlation tell us the relationship between the two variables, right? So I can write this thing, right? It is a relationship between two variables. Also, if I talk about correlation, correlation tells us the strength of relationship between the two variables, that how strongly two variables are related or correlated to each other, right? And the third thing which we can find using the correlation, which is the direction of relationship, right? So these are the things which correlation can help us. Again, I'm repeating, correlation can help us to find the relationship between the two variables. Means we can see how strongly, weakly, or moderately two variables are related to each other. Also, correlation tell us the direction of the relationship, whether the direction means if you are increasing one variable, other variable increasing or decreasing, something like that, that we can find using the correlation, right? As I think Vijay sir and Malvika ma'am said, it is not a causation. Causation means the study of cause and effect relationship. Meaning is that it is quite obvious that two variables, if they are relating to each other, might be possible they are impacting also. There can be a cause and effect relationship between these two variables, but that we cannot ascertain using the correlation, right? So correlation cannot a causation. It is only simple telling us the relationship between the two variables. Is it clear to everyone?
Yes, ma'am.
Yes. So the further, if I talk about the types, What are the types of correlation? Usually, if you refer statistical books, there is variety of correlation like simple correlation, multiple correlation, then there is linear, non-linear. But basically, here we need to understand the two main correlation, that is positive correlation and negative correlation. These are the two important correlation we need to understand here. So when I say negative, negative means when the change or when the direction of change is opposite, it is known as negative correlation. Similarly, when I talk about positive correlation, so when the direction of change
Same direction.
is in same direction, it is known as positive correlation. For example, suppose if I can say, maybe if you have heard, means I don't know how many of you are good in economics and you have studied or not. So in economics, there are principles like supply and the price. So according to the economics rule, generally the rule says, it is from the supplier point of view generally. The rule says when price increases, supply also increases. So that is when one variable is increasing, other variable is also increasing. So the direction of change is same. That is known as positive correlation. Again, rule which I am taking from the economics only. Generally, if I say demand and price, so I think it is well known to all of us and experienced also. Generally, that when price increases for certain products, generally demand gets decreased, right? That means there is a negative correlation. One variable is increasing, other variable is decreasing. So this is known as the negative correlation. So these are the two different types of correlation, which is very important to understand. So if you are getting the correlation value positive, that means it is a positive correlation. If you are getting the correlation value as negative, it is a negative correlation, right? Now, need to know the method through which we can calculate correlation. So generally, their method is Carl Pearson's coefficient of correlation is the method which we can use to calculate correlation. And if you know, we can represent correlation by the small r. This is a representation we are using to represent the correlation. And to interpret correlation, we need to know this thing, that what is the value of correlation. It is in between -1 to +1. So it is because of this, just a minute, I am using some different thing. One of you have suggested previously the this thing, right? So that means r can varies in between -1 to +1. Maximum it can be +1, minimum it can be -1. So according to the value of r, we are interpreting that whether the correlation between the two variables is strong or moderate or low or weak, right? So this is about the correlation. So again, if I will I'll give you a quick recap of correlation. Correlation is what? It is nothing. It is but it is the relationship study between the variables. It tells us the strength, that how strongly, moderately, or weakly two variables are related to each other. Using the sign of correlation, we can identify the direction of the relationship, whether the direction is positive or negative. If I say positive, positive means if you are increasing one variable, other variable will also increase. If you are decreasing one variable, other variable will also decrease. So the change of direction will same. If one is increasing, other will also increase. If one is decreasing, other will also decrease. Second is the negative. So here you can see here the direction of change will be opposite to each other. That means if you're increasing one variable, other is decreasing, or vice versa. If you're decreasing one variable, other variable is increasing. It is known as negative correlation. So you do not need to what I can say, make a myth that correlation can tell you the causation. It cannot tell you causation. It cannot guarantee that there is a cause and effect relationship between the two variables. For that, we will go for the other statistical test. So correlation can only tell us that how strongly two variables are correlated to each other. Method name is Carl-Pearson's coefficient of correlation. Using that, we can calculate the R, that is the representation of coefficient of correlation. The value of R can lies in between -1 to +1, and we can interpret R in terms of strong, moderate, or weak, positive or negative correlation, right? Then I think I need to write one more thing, that is the variable requirement. So variable requirement in case of correlation is we need to have two continuous variable or continuous data we need to have to perform correlation, right? So this is about the, in simple terms, I tried to explain you the correlation. Now I'll talk about the regression and then we will see how we can perform these two using Excel. So regression are a step ahead from the correlation, but to perform regression, you need to know that what is the status of correlation between the two variables. So you need to know whether the variables are strongly correlated or not. Accordingly, it will define the what I can say cause and effect relationship between the two variables. So to study cause and effect relationship or to study causation, we are using regression, right? So it is telling us the causation or cause and effect relationship between variables. Apart from that, I can say if you want to see the influence or impact of one variable on other, that how much impact you can find or measure on one variable of other, that way also we are using regression. So to see the impact or influence of one variable on other variable or variables, right? We are using generally regression. Apart from that, we can also say this thing, if you want to go for the forecasting or the prediction, even then we are using the regression. Generally, it is a modeling which we are doing between the variables. Right? So correlation means correlation is the prerequisite, I must say. So I am writing here correlation is prerequisite for regression. That means it is imperative to find the relationship between the two variables to perform regression. If we are not finding that, even then softwares are giving us the value of correlation between the variables, right? So that will help us to get an idea that how strongly two variables are related to each other, right? So causation type of study, if you want to do, we will go for regression. We want to see the impact of one variable on other variable or other variables. In that case also we will use the regression. If we want to do the forecasting of the one variable using other variables, we want to predict something, even then we are going for the regression. Then the important thing which I said, correlation we are generally using to understand the relationship between the variables, and then we are performing regression. If we are not performing by our own, even softwares are giving us the correlation value first, and then we are going for the regression, right? Now, if I talk about the line number 29, which is talking about the modeling between the variables. So I think in our math class, usually when we were in the schools, we have studied a straight line equation. If you can recall, generally we are writing y equals to mx plus c or a plus bx. Generally, this is the regression line which we all have studied in the school time. Till 10th, I think we all have mathematics, right? So we have studied this equation. So if I talk about this equation, I think priorly also maybe I think I discussed this. So here I can say y is what? Y is the dependent variable, a is the intercept, p is the slope, and x is the independent variable. So if I want to predict the value of y, I need to know these three things, a, b, and x. So a and b are the constant values which we can find in regression. X value you need to put, because according to the value of x, the value of y will be changing. So we can say this thing that x is independent, and because of dependency of the value of y on x, we can call y as a dependent variable. So this is generally a simple mathematical equation. But when we talk about the statistics, so in statistics we can make this equation as a plus or maybe alpha, I might say. So I think I need to go in the insert to use these notations. So other than going there, I'm using alpha in plus beta into x plus the e, that is error term. That is the error term. So this is generally the statistical equation rather than using mathematical equation. Generally, we are writing this equation because whenever we are talking about the prediction, modeling, and etc. So generally, whatever prediction we are making for the variable, it is not necessary whatever is the prediction that will the same actual value we are getting for the variable, right? So that way there is a difference in these two values, and that way we are using here the error term to balance this equation, right? Further, talking about types. So types of regression. Generally, there is two types: simple linear regression and multiple linear regression. So these are the two variety generally which we can talk in terms of regression, although there is variety of regressions available, but using Excel we can perform these two, simple and multiple linear regression, right? So simple linear regression is what? Simple linear regression means it is requiring only two variables. Requires two variables, that is one independent and one dependent, right? And both the variables should be continuous. Then talking about multiple regression, here we need to have one dependent and more than one independent variables, right? So this way, this is the basic requirement to perform regression. Also, in statistics, for each and every statistical test, there are various assumptions available. But usually in Excel, we are not doing this. But still, if I talk about the regression. So in Excel, for the regression, there is a concept of few of the assumptions. Means there is a concept. Using that thing, we can check some of the assumptions of regression. So that I'll show you how you can do that, right? So this was the basic idea about the correlation and regression. I hope the concept is clear. May I proceed further?
Yes, madam.
Yes, ma'am. Thank you. So you need to come on the sheet number 1. I think you have found the Excel sheet shared on the WhatsApp group, right? I hope. Any confirmation?
Yes, ma'am.
Yes. Thank you, ma'am. So you can see that particular book, this particular workbook having so many worksheets. So I'm requesting everyone to open the first worksheet named as correlation, right? In this, you can find we are having two variables. First one is the temperature in Celsius, and second one is the sales of ice cream. That will be the number, right? So here, using correlation, we need to find the correlation between these two variables. That what is the correlation between these two variables? That is temperature and sales of ice cream. So both the variables are continuous in nature, that you can find easily. Temperature is a continuous scale variable. Sales of ice cream can also be a kind of numeric variable, I can say. And that way we can find the correlation between these two variables, right? So now what you need to do, you can come to a blank cell, put a equal sign, then type CORREL. That is the function which can help us to find the correlation. This is the first way I'm telling you. So here you can see we need to pass arrays. Arrays means the range of the data you need to give. So I'm selecting the range number 1, putting a comma, then selecting the range number 2, and then closing the bracket. So I hope you have done this. Everyone?
Yes, ma'am.
Yeah. So once you are doing enter, you would be able to see the relationship between the two variables is coming as 0.774, which is a strong correlation, positive correlation, right? So generally the notation is what? When the temperature increases, the sale means the interpretation for this value is that when the temperature increases, sales of ice cream will also increase, right? Because it is a positive symbol. There is no negative symbol here. So it is a positive correlation and it is strong in nature because, as I said, when the value is in between point, I think I didn't tell you that, but okay, if I forgot, you can write here. If the value of correlation is lies in between 0.75 to 1, it is generally a strong correlation, right? Then 0.5 to 0.75 is a moderate correlation. Then less than 0.5 is the weak or low correlation, right? Then so we can see our value is coming in this first range. So that is why we are calling it as a strong positive correlation between the temperature and sales of ice cream. So this will be the interpretation here. So this was the first way of finding correlation between these two variables. Now the other way is you can use the analysis toolpath. For that you need to go to the data tab. You can go to the data analysis here. Then you can find or locate correlation. Once you will scroll down or scroll up this particular bar, you can find here correlation is there. You can select this and you can press on OK. So this is the dialog box coming. I am selecting my both the variables range here. You can find like this. Then you can see by default option is grouping of the variable is according to the column. So you can find the variables are listed in the column. So this is the by default, we will go with this. But if your variables will be in row, you will go with the row, right? Labels I selected using my, means in my selection, you can find this two labels I have selected. So I'm checking this box here. I want to generate my results on the same sheet. So same sheet means just I'm coming. Yeah. So I'm selecting a blank cell here to generate my output. Now I need to press on only OK. So I hope I can press OK.
Yes,
Yes,
ma'am.
Yes. So you can find this is the output we are getting using the data analysis toolpath. There you can find, if we will see the correlation between temperature and temperature. So for the same variable, correlation will always be 1. Similarly, for sales of ice cream and sales of ice cream, it is 1. But for sales of ice cream and temperature, it is coming point same value, that is 0.774, which is the greater than value for from 0.75. So it is a kind of strong positive correlation between the temperature and sales of ice cream, right? Correlation is clear to everyone?
Yes, ma'am.
Yes. So the next sheet is for the practice purpose for all of you. You can use this sheet to perform correlation by your own. Further, I am moving to the regression sheet. I need to increase the size firstly. Yes. I hope visibility is okay of the data.
Yes, ma'am.
Fine. Now you can see in the regression concept, I have already explained you. In case of regression, we are interested to see the impact of one variable on other, or we want to predict one variable using other variable, right? So here we are having two variables. COVID cases and masks sold. So in this case, you need to define you need to identify which will be the dependent and independent variable, because when I have shown you the conceptual aspect of regression, there I have shown you the regression line also, the model which we were fitting using regression between the two variables y and x. So there I have explained you y is dependent and x is independent. So that is why for performing regression, you need to always identify which variable will be the dependent and which variable will be the independent variable. So can any one of you tell me in these two variables, which variable I need to take as a dependent and which I can take as a marks sold will be
Dependent variable and COVID is independent.
mass sold is the dependent variable and COVID cases is the independent variable. Very correct, ma'am. Thank you. So any software will not do this for us. We need to always define that which variable will be the dependent and which variable will be the independent. Either using literature you can find this thing, or by your own understanding, I think we can say this thing, that which variable can play here the role of dependent variable and which variable can play the role of independent variable, right? So now to perform regression, you need to go to the data tab, need to select the data analysis toolpack. So click on this and then go down to locate regression. I hope everyone has found the regression in their dialog boxes. Then,
Yes, ma'am.
okay, so click on the OK button. Okay, I think fine. Now, what things you need to do here? I am making changes here, and then we will see one more time that what you need to do here, right? Now, in the first section, that is the input, you need to transfer the y variable and x variable. So priorly we have defined or decided that which variable will play the role of dependent variable, that is y variable, right? So I think it was very clear. We are using masks sold as a dependent variable. So that I have selected, that range I selected here. Second variable is x variable. This is your independent variable, which is COVID cases. So I selected the range also. Is it fine? Selection is done.
Yes, ma'am.
Now further, if you can pay attention, I selected my data including the label. So again, I'm checking this labels box. Confidence level by default is 95%. If you want to make changes, you can select this, and using the keyboard you can make changes. But I think it is okay if you are selecting it and making changes, that will change. Otherwise, it will be by default 95%. Constant is 0. Constant
Excuse
means,
me, ma'am.
yes,
Excuse me, ma'am. What is that confidence level? Means why should we? I don't get what is that confidence level.
do you know level of significance?
Yes.
So 1 minus level of significance is confidence level.
Okay.
So
Thank
it
you.
is indicating that 5% is the confidence level, level of significance. That is 95% is the confidence level. That
Okay.
means we will be 95% sure whatever conclusion we are drawing.
Okay, ma'am.
Yeah.
Okay.
Next is constant is 0. So you do not need to check this, because if you can recall the straight line which I explained, that is y equals a plus bx. So where a is treated as a constant, and if you are making it 0, so you will not get its value. So a was the intercept and we want to get its value. So you do not need to check this box here, right? Further, in the output of options, as our notion, I usually select the first option. Up to you, wherever you want to generate your output, you can select that, right? Further, although if you will not select anything, even then you will get the results of regression. But if you want to check certain of the assumptions, you can select the residual plots, line fit plots, and the normality or the normal probability plots. These three you need to check. Done?
Yes, ma'am.
Okay. Then you can press on OK button. In a few seconds, yeah, I think you can see the output. Output is generated for me. right? So firstly, I'll do one thing. I'll keep all these little away from each other so that we would be able to see all of them one by one. Yes. Fine. So firstly, I'll talk about the first table. That is the regression statistics, where you can find the first values coming as the multiple R. That is the R, that is the coefficient of correlation. So which is indicating this is 0.98. 0.98 meaning is there is a strong positive correlation between the COVID cases and masks sold, right?
Yes, ma'am.
Right. So yes. So next is the R square value. In the R square section, you can find two types of R squares are given: R square and adjusted R square. Once, if you are using a single independent variable, that means we are talking about the simple linear regression. So in that case, you do not need to look at this value. You need to only refer the R square value in case of simple linear regression, where we are having only the single independent variable. In case of multiple linear regression, where we are having more than one independent variables, there we will not report R square, where we are reporting the adjusted R square, right? So this is the difference when you need to use this.
Then please repeat this. The
R
last thing.
square we are using in case of simple linear regression, where we are having only the single independent variable. Adjusted R square we will use in case of multiple linear regression, where we are having the more than one independent variables with us.
Okay.
Right? So as we know, we are having only the single independent variable, that is COVID cases. So we will only use here the R square and we will ignore the adjusted R square. So you need to see the R square value is 0.96, which is again a very good figure. So interpretation I'm writing here, what will be the interpretation of R square? So it explains So it explains us the percent variance explained by independent variable in dependent variable. So I can say that 96% variance in mass sold is explained by COVID cases, right? So how much of the dependent variable is explained by independent variable, that we can understand using the R square. In some cases or in some of the books you can also find
Sorry.
you can also find that R square indicates the fitness of the model, whether the model is a good fit model or not. Because if R square will be poor, and R square is related with your R only. So once if you are doing the R square, means you are multiplying R value twice, or you are taking its square. So you will get the same figure, right? So R square is nothing but it is square of your correlation. So if your correlation will be low, R square will also be low, right? And if it is low, that means your independent variables are not clearly or in a better manner explaining your dependent variable, right? So that is why you need to always report R square and R both. So again, I'm repeating that R square indicates the percent variance explained by the independent variable in the dependent variable. So I can say that 96% of the variance in the mass sold is explained by the COVID cases. Still, some of other things can be there which can explain the variation in the mass sold, right? That means there can be some other causes also which are impacting the sales or the cost or the sales of the mass. Fine. Then it's standard error of mean. I think we do not need to interpret and report here. Total observations were 12. Next is the ANOVA table, which is the important table. So as yesterday we have discussed ANOVA, and we have seen that usually for finding the significant difference we are using the ANOVA. But in case of regression, this ANOVA is telling us the fitness of the model or the linearity concept of the regression. So generally it is a simple linear regression. So we are using ANOVA, and we are looking here that whether the p-value of the ANOVA is greater than or less than to your level of significance. So I think we know level of significance is 0.05 and this value is less than 0.05, which shows that the ANOVA is significant here. Means we can say this thing, that model is a good fit here. That is, the model is the good model, or it is helping us in a better prediction, right? So this is the meaning of ANOVA here. Lastly, if I talk about the table which we are finding at the bottom, which is the important table, because this table will give you what? This table will give you the value of your intercept and the slope, that is A and B. So intercept you can find, this is the intercept, that is the value of A, and this is the COVID cases coefficient, which is the B, right? So this is A and this is B. But before reporting these two values, we need to see the T and its P value. So the P value is very important in case of this intercept and the coefficient value. This is indicated in both the cases, the P value is less than 0.05. That means intercept is also significant here and the coefficient of COVID cases is also significant here. Or I can say both are contributing to our dependent variable. Means if you want to predict dependent variable, these two should be significant always, right? So that way you can say this thing, that your model is a good model. So if I come here and I want to make now my model, so I can make my model as mass sold is equals to minus 245.631 plus 0.99456 multiplied by COVID cases. So this would be my model. So for example, this is the model I have made. Now using this particular equation, we can predict the mass or the cells of mass. We need to put here the number of cases on a particular day in a particular city, and then we can simplify this equation, and that way we can predict this will be the cell for the mass, right? Is it clear to everyone?
Yes.
Now,
Ma'am,
yes.
this last equation, can you please explain again? Mass sold equals to.
What I need to explain in this, ma'am?
Ma'am, this minus 2.5, minus 245, that I got it. That is intercept plus, ma'am, 0.99 is COVID cases. Ma'am, into bracket COVID cases, so ma'am, already वो COVID cases तो हम ले चुके. I know, ma'am, that is as per the equation.
So, ma'am, this is B. So we have written here the value of B. X is always a COVID cases. Once you are putting the value of COVID cases and multiplying with this and then subtracting this, only then you will get the mass sold value.
So, ma'am, it will keep on changing, na? 0.06, then
Obviously.
1.
Obviously, it will changing. That is why it is a independent variable. And accordingly, the value of mass sold, that is the value of Y, will be changing.
Okay, ma'am. Okay, got it, got it.
Yes. Now we will come to the graphs. Firstly, I will talk about this normal probability plot. Here I'll suggest you. Okay. You can see here when I think I am not getting that plus sign. I don't know what happened to this. Okay, give me a second. I'm just checking. I need to add a trend line. I'll check from where I can do that. I think I need to fit here the trend line. I am looking for that plus sign which is coming usually adjacent to this particular border of the chart. I don't know why it is not coming from here. I think I am unable to locate that. I'll see one more time if I can find it. Yeah, you can see if you are not getting a plus sign here nearby your graph, you can come to the design. This is a good thing of Excel. Once you are selecting the chart, it will add one more tab to your menu bar. That is the design. In the design, you can find at the extreme left, there is a add chart element. There you need to use this trend line, and that I am using the linear trend here. Fine, everyone?
Yes, ma'am.
Right. Now, what you need to do, you need to see, because normal probability plot, why we are using, there is one of the assumptions of regression, which says that the residuals, that is the error term, should be normally distributed. So this is the distribution of the residuals, and we need to check when we have fitted this trend line, if these data points or these residuals which we are getting here in the blue color, you can see almost they are following your trend line. So I can make a conclusion from this thing that the residuals are approximately normally distributed here, right? And I think it is clear the term residual to everyone, right? I explained the error term. It is clear? Yes.
Yes, ma'am.
Yes. So residuals are the difference of actual and the predicted value. So if your model is predicting something and whatever is the actual value of the variable, so the difference in these two is known as the error term, right? So these are those error terms which are following your trend line. So this is indicating that the residuals or the error terms are approximately normally distributed. Using this particular plot, this is what we have understood. Coming here, talking about COVID cases, residual plots. So generally, you need to see, you are finding here a x-axis which is set at 0. So whatever is the residual points are there in the blue color, you can find they are distributed here and there. So these are indicating the homogeneity of the residuals, whether the residuals are homogeneously or whether the homogeneity of the variance is there in the residuals or not. So variance in the residuals should be homogeneous, and how you can ascertain that thing? Using this horizontal line, you need to see these data points or these residual points should be scattered almost what I can say at the above of 0 and at the below of the 0. They should be scattered randomly, but should be almost in a same proportion to the above 0 and to the below 0. So this way you can ascertain the homogeneity of the variances for residuals. And lastly, we will talk about the line fit. So in the line fit also, you can select the this particular chart, and you can add the trend line here. And again, you need to add the linear trend as it is a simple linear regression. Right. So now you can find the black color line is fitted here, and that way you can find that predicted value or the actual value of the mass is all, that is blue color and the orange color boxes are following the straight line. That means your model is a good fit, right? Understanding, everyone? I hope it is clear, friends.
Yeah, this is clear.
Fine. So next sheet is for the practice purpose. We will take the last sheet for the multiple linear regression now. So I request everyone to open the second last sheet named as MLR.
Yes, ma'am. Done.
Open.
Ma'am.
Visibility is okay of the data points of my sheet.
Yes, ma'am.
Fine. Now we can see here clearly. I think rather than writing the name of the variables, I have written only the symbols to explain you the multiple linear regression. So suppose in this case, we are having three variables available. First one is x1, x2, and the y variable. So as you can see, y variable is what? Y variable is nothing. Y variable is your dependent variable, right? So this is your dv. This is your iv1. This is your iv2. So in this case, we know this thing that the suitable test will be the multiple linear regression, because if I want to see the impact of x1 and x2 on y, right? In that case, we need to use multiple linear regression. I think in the previous case, I forgot to tell you the hypothesis, right? So this time I'm telling you the hypothesis. You can write the hypothesis. There is no significant impact of COVID cases on the sales of mass, or the mass. So, means sales of mass will be the better word to write in case of hypothesis. There is no significant impact of COVID cases on the sales of mass. It is fine.
Yes, ma'am.
Now coming to the MLR, here I'll talk about, we need to make two hypotheses, one for each of the combination of dependent and independent variable. We can say this thing, there is no significant impact of x1 on y, and there is no significant of x2 on y, right? This way we are making two hypotheses, and to fit the multiple linear regression, you need to go to the data tab, you need to go to the analysis toolpath, and then regression is already selected. You need to click on only the OK button. So we are removing the previous selections. Right. Now I am shifting the y variable range in the input y range, and for the input x range, you need to select both the variables of x simultaneously. Right. So we will give this range of x variables simultaneously in the input x range. Labels are selected. So you need to check the labels box. Confidence level, if you will not select, even then you will get the results at the 95% confidence level. That is 5% level of significance. Output option, I will go with the first option. Then this time I'm not selecting anything to show you that only this selection can also give you the results of regression, right? So you can click on the OK button to get the outputs. So I hope it is fine. May I press on OK?
Yes, ma'am.
Yeah. So I think you can see we are getting the output here. Firstly, I'll talk about the summary output of regression, which is telling us, which is talking about the multiple R, which is 0.8365, which is a strong positive correlation. Sign is positive. So that is a strong positive correlation. Second one is R square, which is 0.69. So this is again, I can say around 69 or maybe 69.9. That is 70% approximate. So approximate 70% of the y variable is explained by x1 and x2. But I think I forgot to tell you. I think I have already told you this thing. We will not report R square here, as we are having two independent variables. So I think you should report here the adjusted R square, right?
Yes,
So
ma'am.
the interpretation, yeah. So the interpretation will be approximate 61.4% of y is explained by x1 and x2, right? Although the percent is low, but 60% is okay. But if it is less than 60, generally there is a problem, right? Standard error is 6.58. Observations were 10 in number. Coming to the ANOVA table and looking at the significant value of ANOVA, we can say this is less than 0.05. That means we can say model is a good fit here. Now talking about the intercept value, which is 43.10919. X1 is minus 0.818. X2 is 2.41. You need to check whether these three are significant or not. So we need to look at the p values. All the three p values we can find are less than 0.05, right? So that means we can say all the three, that is intercept, coefficient of x, coefficient of x1 and x2 both, means are significant, or I can say they are significantly contributing to the dependent variable. So our line will be y equals a plus b1 x1 plus b2 x2 can be represented as y equals 43.109 minus 0.818 into x1 plus 2.418 into x2. So this will be the model, or this will be the model we have fitted, or a straight line we have fitted between the x1, x2 and y. Clear to everyone? If you want to predict y, you need to put here the various values of x1 and x2, and then you will get the value of y. Is it clear?
Yes,
Yes,
ma'am.
ma'am.
And we can say this thing that our both the null hypothesis will be rejected here, and we can say this thing, or we can conclude this thing that x1 and x2 both are significantly or impacting the y variable, right? Yes. So I think this was the correlation and regression. So now I will summarize all the sessions today, so that tomorrow, if I will talk about the cases or situations, tomorrow will be what? Tomorrow I'll show you certain situations, or I can say I'll try to explain you few of these caselets, small caselets, 2-liner, 3-liner, something like, and you need to read them, and then you need to tell this thing to me, or we need to discuss this thing, that which test will be the applicable test there. So that will help you to enhance your understanding. If this is the situation, in the situation which test you can apply on, right? So for the purpose, now I'm summarizing all the 4 days session today for you. So if you want to write something, make your notes or something, that you can do, right? So I'm starting with day 1.
Just a minute, ma'am, please. Just a minute.
Yeah. Shall I start?
Ma'am, just a second, ma'am, please.
Okay, I'm waiting.
Yes, ma'am. Yes, ma'am.
Fine. Everyone is okay. May I start?
Yes, ma'am.
Yes. So I'm starting with day 1. On day 1, we have discussed the descriptive statistics, and also I have discussed the chi-square test. So starting with the descriptive statistics, there I said this thing to all of you, that generally when you want to get the understanding about your data, when you want to know the nature and insights of your data, we are using the descriptive statistics. Or to summarize our data, we are using the descriptive statistics, right? This is what we have seen on day 1. And then I explained you the methods which can help us to summarize the data. So methods are the measures of central tendency. Next is the measures of dispersion. Next is measures of distribution. So these were the 3 methods which we have seen, and in that we have seen what are the measures, or the, what I can say, methods we can use to see or to get the summary value of the, or the summarized data values. So in that I have explained you mean, median and mode comes under the measures of central tendency. In case of mean, median and mode, again there was a clause I told you, when the variable is continuous, numeric variable we are having, or interval or ratio scale variable we are having, we need to always check for the mean value. And if you are having the categorical variable, that is nominal or ordinal scale variable, in that case we can go for the mean and mode, right? Further, we have talked about standard deviation and variance. These two will also be applicable in case of numeric or continuous variable. And these two help us to identify or to find the deviation in the data from the mean. Because all the data points will never be the same. So there will always be some deviation from the mean value, and standard deviation and variance will help you out to get that deviation, right? Then further, we have seen the dispersion of distribution. Oh, sorry. We have seen the measures of distribution, that is skewness and kurtosis. So I explained you skewness is nothing but it is a study or it is a measure of asymmetry in data, whether the data is symmetrical or not, that you can study using the skewness value. If the skewness is 0, that means your data is symmetrical to mean. 50% data will be at the left hand side of your mean, and 50% data will be at the right side of your mean, right? So that way you can see the skewness value. But if it is positive, there is a positive, or your data is positively skewed. If it is negative, your data will be negatively skewed. Then talking about the kurtosis, so there also I told you for the normal distribution, generally the kurtosis value should always be 3, right? And then I explained you, if kurtosis value is positive, that means your data is leptokurtic. But once your data is negative, your data is platykurtic. When you are getting the kurtosis value as 3, that means you can say this thing, that your data is perfectly normally distributed, right? So this is generally kurtosis will tell you about the sharpness of your bell-shaped curve, and also the tails status, whether the tails are heavily, what I can say, most number of data points are falling on the tails, or less number of data points are falling on the tail, that you can study using the kurtosis, right? Further, I explained you nominal and further I explained you the non-parametric and parametric tests. So I said, when we are not bothering about the normal distribution, when we are considering the categorical data, we will go for the non-parametric test. And in that category, I explained you the first test, that is the chi-square test. And I explained you chi-square test is generally we are using as a non-parametric test, and it is having the 2 categories, that is the goodness of fit and the independence of attributes, right? So goodness of fit meaning is we are having the single categorical variable, and we are looking for the uniform distribution of the frequencies for all the categories of that variable, right? Further, I explained you the second chi-square test, that is the independence of attributes. So there I explained you we will be having the 2 categorical variable, and by taking their categories, we will make a contingency table, and we will put all the observed frequencies there, and then you need to calculate the expected frequencies. And that way we are generally interested to see whether the 2 variables are related or independent to each other or not, because it is independence of attributes. So whatever 2 attributes that is categorical in nature you are considering, you are interested to see whether the 2 attributes are independent to each other or not. So this was the chi-square test. Further, I discussed the t-test, and I said this thing, that generally the purpose of t-test is to find the significant mean difference. So limitation of the t-test is that means firstly I can see the type. So it is 1 sample and 2 sample. In case of 1 sample t-test, we are comparing the sample mean from the population mean. In the 2 samples t-test, we are having independent samples and the paired samples t-test. So the limitation of the independent samples t-test is that it can compare only 2 groups, right? That is why it is known as the 2 samples t-test. So it can only compare the 2 independent samples, and that is why it is limited for the 2 categories or 2 groups only. Further, the dependent samples or the paired samples t-test, there we will be having the dependency of the 2 variables, or I can say 1 variable we will only measure there, and 2 times you need to measure that variable for the same set of people. You need to measure that variable. After a particular period of time, you will measure that variable for the same number of people. So this is known as the dependent samples t-test. Further, I talked about ANOVA. In ANOVA, I have told you this thing, that when we talk about the one-way ANOVA, so one-way ANOVA is a step ahead from the independent samples t-test. In case of independent sample t-test, we are considering only 2 groups. But if you are having more than 2 groups and you want to compare the mean of all the groups, you can go for the one-way ANOVA. So you need to have only 1 categorical variable with the more than 2 groups and one dependent variable. Then talking about the two-way ANOVA, there you need to have 1 dependent and more than 1 independent variable. Generally, 2 independent variables you need to have and 1 dependent variable you need to have to perform two-way ANOVA. And there are 2 cases, replication case and without replication case. So the replication case is what? Whatever variable, categorical variable you are taking in the row, right? So there, if the categories or the groups of the categorical variable are repeating and they should be repeated in the same number, in that case, this is a case of two-way ANOVA with replication. Fine. Then the next case is the without replication. So whatever variable, categorical variable we are taking in the row, so the categories will not be repeated there. So in that case, we can say this thing, that is a case of without replication. So this was about the ANOVA. ANOVA and T both are generally finding the significant mean difference. Today I talked about correlation and also I talked about the regression. So I told this thing, correlation indicates only the relationship between the variables, that is strength and direction we can find using the correlation. Generally, we are looking for the positive and negative correlation that we can ascertain using the sign of the R, and R is nothing but it is a coefficient of correlation. And generally for calculation coefficient of correlation, we need to have two continuous or numeric variables. Then I explained you how to perform correlation, and I told you the range of R, it is -1 to +1. And also I have what I can say, subdivide these ranges in the form of strong, moderate, and the weak correlation. And then I said the limitation of the correlation is that it cannot help us to find the causation type of study, or if you want to see the impact of one variable on other, that we cannot ascertain using the correlation. So for the purpose, we need to go for the regression. There in regression, we can find cause and effect relationship, means which variable is cause, which variable is effect, which is making impact on which variable, that you can ascertain using the regression. And also we can use regression for the prediction purpose, forecasting purpose, or modeling purpose, right? Then I explained you simple and multiple linear regression equations we have seen, and we have seen how to perform these two using the Excel. And I also explained you the assumption part of the regression using the Excel. So this was the summary of all the 4 days concepts which we have studied till now. Tomorrow, I expect from you people, tomorrow, as I said, my role will be very minimal. I will only read the situations for you. I'll wait for your answers and then we will discuss that. So I'm expecting you people to little interactive tomorrow, so that the session will be fruitful for all of you. So this is all from my side for the day. Now the platform is open for questions and answers. So if you are having any, please ask.
Ma'am, I have one doubt. Ma'am, in non-parametric test, we take chi-square test.
Yes.
We take, ma'am, in parametric T test and F test and Z test are included. Maybe
T,
I
Z,
have,
ANOVA, yes, ma'am.
okay. T, Z, F test and ANOVA. Okay, ma'am.
Ma'am, means wherever we are talking about standard deviation, variance, mean, etc. So these all tests come under the category of parametric test. If you say or if you pay attention on the chi-square test formula, there I have told you it is based on the frequencies, counts,
Okay.
right?
Ma'am, if I have to differentiate between parametric and non-parametric, one is the type of test, and one is that in non-parametric frequency is being tested, is being studied, and in parametric the standardization of the variables is being studied. Is it correct?
It is not always. In case of non-parametric test, we are also considering median.
Okay.
Means when your data is not following the assumptions of that particular test, I'm talking about the parametric test. In that case, generally it is suggestive you should go for the non-parametric test category. So as the variables are continuous in case of parametric test, so generally we are suggested to apply the mean. But if your data is not normal, you can go with the median also. So it is not necessary always. You will always only consider frequencies in non-parametric. You can consider median also.
Okay, ma'am. Okay.
Okay, any other question?
For the non-parametric test, ma'am, what is the criteria or what are the characteristics that are required for non-parametric test?
Sir, as I said, I think we have discussed only the chi-square test. For chi-square test, as I said, it is requiring one variable, one categorical variable, or two categorical variable, right? So that is the requirement of the chi-square test. But when we talk about other non-parametric tests like the Mann-Whitney-U test or maybe the Crystal-Wallis test, so Mann-Whitney-U test is the substitute of the independent sample t test. So the requirement of the variable will be almost similar. There will be one dependent and one independent variable in case of Mann-Whitney-U test, right? Although the variable nature will be ordinal, but again I'll repeat the same thing which I said to the Ketki ma'am, that if your variables are continuous but they are not following the assumptions of the test, and in that case also if you are performing non-parametric tests, so they will be like that only. So it is up to us which type of test we are using. So I'll say this thing, Kruskal's-Wallis test is the substitute of the one-way ANOVA. So there we will be having the three categorical variables, right? Ordinal or nominal, something like. So that is, you need to understand this thing, which test you are using and what is the substitute of what. Accordingly, number of variable requirement will be same. But again, I'll mention one thing. If your data is not following the assumptions of the particular test, so generally you can switch from the parametric to non-parametric. But I think as per my assumption, observation, which I have seen nowadays, usually people are not mentioning the assumptions, right? So that will be the call of author, whether you are mentioning the assumptions or not, or without checking the assumption, you are going for the applying of those tests. Because the main assumption is generally the normality assumption, that whether the data is normally distributed or not. But in statistics, there is a theorem called central limit theorem, which says if you are increasing sample size, so generally your data is tending towards to the normality. It is showing you the normal distribution. So when the sample size is sufficiently large, so usually people are not testing the normal distributions and all, right?
Okay, ma'am.
Ma'am, for seeing into cause-effect relationship, you said only regression can be applied. You cannot apply F. This is ANOVA.
ANOVA usually is for the significant mean difference, man. It is made to
see if we want to see the cause-effect relationship. Suppose 2-3 variables are affecting dependent variable. In that case, only regression can be applied.
generally regression is meant for this, ma'am. Regression is and telling us the forecasting. Forecasting is only possible when we are having this cause and effect relationship. So ANOVA can only tell you the significant difference in the two variables. Although variable can having the cause and effect relationship, but I think that we cannot ascertain using the ANOVA.
So we cannot prove this hypothesis with ANOVA that they are having effect on
No,
dependent variable.
no.
Okay. Only the mean difference.
Only the mean difference we can see.
A part of it is.
Yeah. And as I said, today we have seen also, ANOVA is also comes under the one of the assumptions of regression. So ANOVA is there available in regression to ascertain the linearity, or I can say the goodness of fit of the model.
Okay.
And coercion is also comes under the regression. We have already seen today.
Ma'am, one more question. Ma'am, this measures of central tendency we take as mean, median, mode. Measures of distribution we take as skewness and kurtosis.
That is the measures of distribution.
Yes, ma'am. Distribution is skewness and kurtosis.
Kurtosis.
And when measures of dispersal,
Dispersion, standard deviation, and variance.
standard deviation. Okay, ma'am.
Anything else? Nothing?
Ma'am, when is your next SDP scheduled, madam? This is very well.
Ma'am, I think that RFI can tell you, because generally RFI is doing promotions. They are generally organizing the FDPs. So RFI can tell that thing. I don't know.
If somebody from RFI is there, please let me know, because it's really interesting, ma'am. Otherwise, understanding these things so nicely is very difficult. This
Yes,
is what my
so as I think in one of the sessions I said this thing with the other software, because I think one of you have asked me about the SPSS and I said it is
I
the
asked it, ma'am.
Malvika ma'am asked, right? So
Yes.
probably I'm coming with new software soon. Probably today I'll work on that. I'll get a time today. Today is off. Tomorrow is also off because of Janmashtami. So
Ma'am,
probably
usually psychology people uses SPS.
this. It is not psychology people, ma'am. Social sciences means all the domains which are coming under the social science. They are using SPSS.
That is why we are finding different formulas over here in Excel.
Yeah, it is like because ma'am Excel is not that much updated. SPSS is for those people who are not much good with the statistics. They can only go there and perform, only transfer the variables and get the things, right? But here in Excel, as it is used for some other purposes also, so I
Right.
think we cannot expect that thing from Excel.
Certainly, this is helpful for us. One more thing, ma'am. What is variance and difference between variance and SD?
Standard deviation is, ma'am, there is a relationship between standard deviation and variance. When you are doing the squaring of the standard deviation, you are getting the variance, right? So
Okay.
generally, means we can say this thing when because it is based on what if I say in a simple language about the standard deviation, I'll say it is what it is, but nothing but it is the square of the deviation, or it is the average of the square of the deviation, and then you are taking the square root of this, right? So variance
And SD standard error of deviation.
no, SE is different. SE is the standard error of mean, SD is the standard deviation, and VAR is the variance. So standard deviation and variance are related. If you are squaring standard deviation, you will get variance. Or if you are doing the square root of variance, you are getting the standard deviation.
Okay.
Standard error of mean is different. That is an error which we can say, I don't know how much statistics you people have studied. If you are knowing about the with replication case or application case, if we are drawing a sample from the population, I think I explained that thing. So suppose there is a large population, right? Maybe 10 lakhs or something. Suppose I have picked a sample of 100, right? I have calculated the mean, fine. Similarly, so many other samples I am picking from the same population, and for each sample I'll calculate the mean. So for all the means, because suppose I have collected 100 samples, so I will having the 100 mean value, right?
Right.
So I will calculate the standard deviation for those mean, and that standard deviation is known as a standard error.
So you mean to say errors calculated from all scores?
All source means
All scores, different scores you have taken from different.
source will be same, population source will be same, ma'am. I said from the same population we need to pick these different samples. So what these softwares does, these softwares are not picking the various what I can say samples. They are whatever sample we are providing to the softwares. From that they are making so many permutation and combinations, and then they are collecting calculating the standard error of mean for us.
Okay. Okay. Thank you.
Thank you, ma'am. Anything else? How many of you are having off tomorrow? Tomorrow is Janmashtami. It's off?
yes, ma'am.
Okay.
Yes,
No,
ma'am, it is off.
So can we plan tomorrow also little earlier?
No,
Yes,
ma'am.
if possible.
Little
If it is
earlier?
possible, then we can have.
5:30 is okay? Ma'am?
Yes, ma'am. 5:30 is okay.
Yes, yes.
Because tomorrow I am having a FDP for IIM. So I think if it is possible, can we keep it 5:30?
No problem, madam.
Thank you, Hitesh sir. So
Yes.
tomorrow we are meeting at 5:30. Fine?
Yes, ma'am.
Thank you. So
Thank
this
you,
is
ma'am.
all. Okay. So this is all from my side. Happy learning and have a great Sunday ahead. We are meeting tomorrow for the last session. Thank you so much, everyone.
ma'am.
Thank you.
Thank you,
Thank you,
ma'am.
ma'am. Thank you. Thank you, ma'am.
Thank you. And one request from my side for tomorrow, if you people can switch on your cameras, I can capture your pics, right?
Okay. Okay.
Okay, fine. Thank you.
Thank you, ma'am. Thanks.
So, yeah, thank you. Yograj sir, we are done for the day. We can call off a meeting. Thank you so much, Yograj sir. Thank you.